Now let's talk about logarithms. One thing you must understand about logarithms is that logarithms and indices are closely related. So we can say that logarithm is the same as the power or index in the original expression. The base in the original expression is the base of the log. Now, for us to understand this, let's consider an example. Let's assume I have 8 is equal to 2 raised to power 3. Now remember, this is indices. What I've done is to express 8 as 2 raised to power 3, which is 2 times 2 times 2, 3 times, and that is equal to 8. Now, it is possible for me to express this as a logarithm. How? Now remember, this is the base in indices. So a logarithm is going to be log to base 2. 8 equal to 3. Now, if this is equation 1 and this is equation 2, then we can see that equation 1 and equation 2 are the same. The base of the indices, 2, is the base of the logarithm. So with this, let us establish a general form of a logarithm. So if I say if x is equals to a raised to power n, then what I'm saying is this, that log the base, it's a rather, very good, x is equal to n, which is the power. This is the general form of a logarithm. General form of a logarithm. Now, remember this because we are going to be applying this principle and solving questions involving logarithm. Now, let's take, for example, let's look at some examples. If I have number 1, x is equal to log to base 2 or log 16 to base 2, what is the value of x? Now, this is very easy. Now, I'm going to rearrange this equation so that it can be easier for you to comprehend what I'm going to do. Now, let's take the right-hand side to the left-hand side and take the left-hand side to the right-hand side. It's the same thing, which is log 16 to base 2 is equal to x. They are the same, nothing changes. Now, if I'm going to solve this question, what do? The base is 2. So it's going to be 16 equal to the base, and then the x will be the power. I hope this will be easier to comprehend now. I just want to look for an easier way for you to express your logarithm equation into indices. And so this will be 2 raised to power 4, because 2 times 2 times 2 times 2, 4 times 16. And this is equals to 2x. See, we are back to our indices. Remember, when you have a math like this, what do? You equate powers because the base are the same. And so 4 is equal to x. Therefore, x equal to 4. That's not difficult, right? Let's try out number 2. If I have 4 equal to log y 81, find y. Again, I'm going to rearrange my equation so that it's going to be easier for you to understand what I'm doing. 81 is equal to 4. And so this 81 will be here, and the y, the base, and then the power becomes the 4 you have there. So the arrangement of this equation is easier now, right? Express 81 in indices, and that would be 3 raised to power 4. 3 times 3 4 times is equal to 81, and that's equals to y raised to power 4. The base here is 3. The base is y. So at this point, what do we do? Because they don't have the same base. But don't forget something here, that the powers are the same. The power here is 4, and the power here is 4. So what do? In instances like this, it is also possible for you to get your answer. So what we'll do this time, we equate not powers, but we equate base. And then cancel out the powers. 3 is equals to y. Therefore, y is equal to 3. Very easy. And let's try number 3 example. Number 3, I have 2 is equal to log n to base 5. If I have a work like this, what do? Again, I'll rearrange my equation. I'm doing this because it's easier for you to understand what you're doing when you follow these formats. Is equal to 2. So once it's like this, you rewrite your n, the base will come here, and the 2 becomes the power. So n is equal to 5 raised to the power 2, and which is 5 times 5, and that's 25. Very easy, right? Now let's establish another principle that could guide us. If I say 10 is equal to 10 raised to the power 1, then I'm saying that log 10 to base 10 is equal to 1. If I say 5 is equals to 5 raised to the power 1, then I'm saying that log 5 to base 5 is equals to 1. The same principle, if I say a is equals to a raised to the power 1, then I'm saying log a to base a is equal to 1. So what's the point? Once the base is the same with the number you have here is equal to 1, 5, 5, a. If that will help us to understand what I'm trying to do. So with this in mind, let's assume number 4 question asks us to evaluate log 27 to base 3. So if I have a question like this, what do I do? It's still the same principle. I could say the way I've been solving the other one, let log 27 to base 3 be equal to x, whatever you want it to be. And then this is your 27 equals to 3 raised to power x. And this is 3 raised to power 3 equals to 3 raised to power x. Now, here you can equate powers. Since the base are the same. And so 3 is equals to x. Therefore, x equals to 3. That's easy. But let's assume I don't want to follow this method. What is another method I can use to solve this? In applying what I have just mentioned here, that log 10, 10 is 1, log 5, 5 is 1, log 8, 8 is 1. It doesn't really matter what the base is and the number that is there. As long as they are the same, they are equal to 1. Now, I can solve this like this. Log 327 is the same thing as log 3 raised to power 3. 3 raised to power 3 is 27. Now, this power can come to the side of the logarithm. This power comes to this side and becomes 3 log to base 3, 3. Now, recall log 3 to base 3 is equals to 1. So 3 log 3 to base 3 will be 3 times 1. And that gives you 3. Same as the answer we got here. So what's the point? I always tell my students, solve math the way you understand and not the way someone else understand. Not even your teacher. That way, it's easier for you to understand what you're doing and math becomes easier for you. So whatever method you use here will give you the same value. Now let's look at number 5. Number 5 says evaluate log 1000 to base 10. What method will I use? Well, I'm going to use the sub method and then you decide which one is easier for you. So let's start with the first method. Let log 1000 to base 10 be equal to y. And this will be 1000 equals to the base 10 raised to power y. This is the same thing as 10 raised to power 3 equal to 10 raised to power y. So the base are the same, so you equate powers. When you do that, cancel out, therefore y is equal to 3. Okay, let's try the second method. This is log 1000 to base 10, which is the same thing as log 10 raised to power 3. And 3 come to the side and becomes log 10 to base 10. Now recall, log 10 to base 10 is equals to 1. So therefore I have 3 times 1, which gives me 3, same answer. So like I said, it doesn't matter which method you use the one that is easier for you. Let's look at number 6. Here I'm to evaluate log 1 over 7 to base 1 over 27 to base 3. Now when you see a question like this, at first you're going to be confused. What do I do here? It's still no big deal. It's the same process. Whatever we're going to do will give us the same answer. Nothing will change. Again, I'm going to use the same two method. Which one is easier for you, you use. This is the same thing as log 1 over 27 to base 3. Let it be equal to x. You can use any letter of your choice. This is 1 over 27 equal to the base 3 raised to power x. This is 1 over its inverse is the same thing as 27 raised to power minus 1 equals to 3 raised to power x. This is 3 raised to power minus 3 because 3 times 3 times 3 3 times will give you 27. And because of this minus, the inverse, you put a minus there, equals to 3 raised to power x. Base are the same, so as usual, you equate powers. And if you do that, your x will be minus 3. Easy peasy, right? Now, it's the same thing if you decide to use the second method. Log 1 over 27 to base 3. This is the same thing as log 27 raised to power minus 1. Now, minus 1. Okay, that's inverse. What is the next step? This becomes log 3 raised to power minus 3. Now take the power to the side, minus 3 log 3 to base 3. Now recall, log 3 to base 3 is equals to 1. So minus 3 times 1, that gives you minus 3. Same as the same answer. So it doesn't matter what method you want to use. Now this is another technical question. Evaluate log 2 to base 8. As usual, this is log 2 to base 8. Let it be equals to y. This 2 will be equals to 8 raised to power y. And this is 2 equals to 2 raised to power 3y, because 2 raised to power 3 is 8. Now, at this point, it's possible for us to equate powers because the base are the same. Here, the base is 1. The power is 1 rather. So 2 is the same thing as 2 raised to power 1. We've established that before now. So 1 will be equals to 3y. Divide both sides by 3. Therefore, y is equals to 1 over 3. Now let's try add the last example, number 8. I'm to evaluate log 32 to base 4. So let's log 32 to base 4 be equals to n. So let me use another letter this time. This is 32, 4 raised to power n. I cannot express 32 to have 4 as its base, but I can do that for 2. 2 raised to power 5, which is equals to express 4 and becomes 2 raised to power 2n. That way you have the same base and then you can equate powers. If you equate powers, the base will go away. It becomes 5 equals to 2n. Divide both sides by 2, and therefore n is equals to 5 over 2. And then you can decide to leave your answer, which is 2, 1 over 2 as a mixed fraction. Okay, I have some exercises for you. 5 questions. Number 1, y is equals to log 27 to base 3. You have to find y. Number 2, x equals to log 64 to base 4. You have to find x. Number 3, 3 equals to log 27 base y. You have to find y. Number 4, you're evaluating log 1 over 16 to base 4. And number 5, you're evaluating log 3 to base 9. Work this out, put your answer in the comment section. Let's see who will be the first to get all the questions correctly. Watch out for the next video. See you on Logarithm.